Hello everyone, hope you're doing well. Welcome back to my channel. Today I will be sharing the solution for the day 21 of the October daily LeetCode challenge, as you can see in the link itself. I will give you the question link also in the description of the video. So this question is something good. That's why I took this question so that I can show you the way that I am doing it. Okay, and I will also show you one dry run of one of the complicated test cases that we have in this. Okay, apart from the test case given to us, I'm also taking additional test case, and I will be showing you the dry run for this. Okay, so coming to this question, it is 1593. Split a string into a max number of unique substrings. Okay, we'll see that what it is. Max number of unique substrings. See, name conveys some meaning here, but yeah, we will see the whole question also. Okay, yeah, what it is. See, in the input will be given a string, and in the output have written a number. Okay, so let's see the question now. Given Okay, let me zoom in. Given a string as written the maximum number of unique substrings that the given string can be split into. Okay, yeah, you can split stringers into any list of empty substrings. Okay, sorry, non-empty substrings, a list of non-empty substrings where the concatenation of the substring forms the original string. Remember, see, this part is very, very important because see, you can break it into substrings, but the condition they have given here is you have to break it in such a way that after joining them it forms the original string. Okay, and the substring should be unique. So we have two conditions now. Okay, what is the first condition? The substring that we are going to do should be unique in itself. Okay, none of the substring should repeat. That is first condition. The second condition is that the concatenation of the substring that we have formed should match the original string. Okay, that is the second condition. Okay, fine. However, you must split the substrings such that all of them are unique. Okay, these are those. Okay, one of what is the third constraint? Third constraint, we have written the maximum number of such substrings. Okay, so we have three sub questions here. Okay, what are each one of them? First thing is we'll have to break the given string into unique substring. Okay, that is the first question. Okay, next we have to break them in such a way that these substrings when concatenated forms the original string. Okay, and the third one is we have to do that is we have to do the formation of the substring in such a way that we get the maximum number of substrings. Okay, that is the third thing. Okay, I hope you have got the question now. Okay, coming to the first test case. Okay, here it is given, so you have to see that. See, first I will take A. Okay, then I will take B because B is also unique. And remember, you have to find the maximum number of substrings. I cannot take A again, so I will take A and B. That's the way they have done it here. Okay, and then I will take C. Okay, I cannot take C again. Okay, I cannot take this C again. So yeah, this C. So I have to take the last two C's together. So like this. Okay, yeah, we'll be getting it like this. So total, the maximum number of things possible is 5 in this case. Okay, coming to this, you can have A, then you can have a BA. Okay, because you cannot have A alone, so we'll have to have a BA. Okay, A and BA. Here only one. Okay, so see, I will show you the dry run of one of the test cases that will be making you realize that this particular question is more than just you can say, like, see, not simply parsing. Okay, it's more than that, because you will have to be backtrack in some of the cases that we're going to see now. You'll have to backtrack in some of the cases. Okay, for example, if I take this particular string itself. Okay, let me take this string first because it is smaller one, and you will be it will be easier for you to understand instead of showing a bigger example. See here, so what I will take first I will take A. Okay, let us say A is not there in our unique list, so this will be my first substring. Okay, then I take B here. Okay, then again A comes. Now A comes. So remember, I cannot have A. Okay, separately because A is already present. Okay, and remember, the substring must be concatenated to form the original thing, so I cannot leave this A also. Okay, I cannot leave this A. So what I have to do, I'll have to backtrack to B. Okay, when we had this B, I cannot have this B alone, so I will be trying to merge B with A, and I will have BA. I hope you are getting what I'm saying. Okay, so the answer is these two substrings, and I obviously, when I combine them, I get the original one, and in this case the answer is 2. Okay, because I can make only two substrings and not three. Okay, that is one of the yeah, examples. Now coming to this particular this thing. Okay, so let me quickly do this answer for you. Okay, first part will take a W. Okay, we'll take the two W's. Remember, after taking one W, we cannot have another single W again. Okay, and we'll take two W's now. Okay, in this case, again, I can take a Z separately, I can take a F separately, I can take a V separately, I can take a E separately, I can take a D separately. Okay, I can take a D separately, but after that W comes. Remember, after D again a W comes. I cannot have a W separately. Okay, so what I have to do, either I have to merge that W with this D, or I have to merge that W with the coming F. Okay, either one of them you can do, but remember which is the best case, that you will have to see. Okay, so in my case, because since I have a single F already, so it will be better for me, okay, to merge it with F. Okay, but since I have a separate F already, so I will be taking WF in this case. Okay, WF. After that, what I have V, H and WS. Okay, what I have to do, obviously, see here, V, I cannot take again because V is already there. Okay. So what I will have to do, I have to merge V and H. Okay. As simple as that. I have to merge V and H. Okay. Now done. Next, I have S. Okay. S, do I have it anything? Okay, I don't have anything. S. Okay. Finally done. Now I have two W's remaining. Okay. I try and see. I got to know that there is nothing after this. Okay, so I cannot merge it with something else in the front direction. Okay, so what I have to do in that case, I will have to backtrack. So what is this backtracking? See, I cannot have a single W. I cannot have two W's again. Okay, these two are remaining, and I have to remember include them, because if I don't include them, if I conquer the substring without taking them, I will not get the original string back. Okay, remember that. So what I will have to do, I will have to merge them. I will have to merge them with the previous string, that is S. Okay, previous substring, that is S. So this is where the backtracking comes. Remember, once I am processing S and going forward, I will have to come back again. That is what I'm trying to show you, that here a backtracking is involved. So in this case, if you see how many you are having, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, here 10. But remember, this may not be the ideal case. I will show you the same, for same test case, I will show you what my answer will be printing. I will show you the same. See, in this case, you might be thinking this is the best answer, but let me tell you that this here if you count the substrings, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10. But remember, 10 is not the answer in this case. The answer is 11. But it's, in this way it is giving 10. So the idea here is you cannot be, moving with just a single idea. Okay. So see, I did a greedy approach initially. Okay. What I felt best, I just took that. So I got this answer. This is also one of the valid answer, but remember, we have to return the maximum number of substrings that we can make. So this particular thing is giving the, the sum of substrings as n. Okay, let me call it number of substrings. Okay, okay, let me call it hashtag answer. Okay, hashtag answer in this case is 10. Okay, but the real answer is 11, which is not, obviously we have written 11 only and not 10. Okay, yeah. So I will show you the same thing when I after explain the code. Okay, I will come back to this. Okay, remember this thing. So what we have to do, one thing is clear, that we cannot move, with the optimal, see, there is no ideology which is optimal in this case. Okay, we have to do a hit and trial method only. Okay, we simply cannot be passing the string and, getting the answer here. We will have, simply backtracking will not work. We'll have to take every possible case, and then if needed, obviously we'll have to backtrack also. So one thing is very clear, the approach which I showed you, okay, which, works with the examples given, okay, which works for this also. But remember, what we got to know is that this may not work always. Here it is written 10 as the answer, but the original answer is 11. Okay, so we'll have to try all possible cases. And remember, one more thing that I want to show is that here the length of the input can be at a max of 16. Okay, so 16 is really a small number. You can try all possible cases here for that reason. Okay, so that is something that I want to show. Even if you, have exponential time complexity for this particular n, that is fine. It's not going to matter much. Okay, so yeah, that is another thing that I want to tell you. So given the constraints and given the uh, you know test cases that we are having, one thing that we are clear is that we will have to try something where we are trying every possibility. Okay, we are not leaving anything. What I did here, I took a W initially, and then because I cannot have a single W, I took two W's. So like this we should not do. Okay, we should also have a test, a possibility where I can take all these W together, which you will see in the solution that I'm going to show you. Okay, I will show you that also. So that is the basic idea. Okay, we should not be moving like this. Okay, this W came first, so I will take this. Then I cannot have a W, so I will take this W. See, this ideology is not the correct one. Okay, we should try all possibilities. That is, I can take this three W's together also if needed. Okay, that also is one of the possibilities that I should explore. Okay, so in my solution, I'm going to explore that. What I'm going to do, first of all, I'm capturing the length of the given string to me. Okay, I'm declaring answer. This will be my final answer that I'm going to return. Okay, here I'm writing the answer, as you can see. Next, what I'm doing, I am declaring a function. This whole function is, actually solving the whole question for me. I will do this is the whole function, by the way. I am doing the function call here, and then I'm returning the answer here. Okay, and if you have been following my video, one thing will be very clear for you is that this thing will be crystal clear, is that you will have to declare non-local whichever, thing you are using outside of this function. Okay, so in this case, and answer are declared outside of this function, so I will be declaring them as non-local inside my function. Okay, as simple as that. Remember, this is the given function. Okay, this is the given function. Inside that, I'm declaring another function, I'm using it. Okay, so I have to declare it as a non-local, as simple as that. So see, whenever you're defining a recursive condition, that is a recursive function, what you have to do, you have to include a condition, okay, which will terminate the recursion. That is, it will stop the recursion from going in unlimited way. Okay, so this is one such condition that I'm doing. Okay, this condition must have a return statement as well, otherwise it will not, stop, right? This is the thing. Okay, I will explain the whole thing, but let us see first what I'm doing. See, this is a function call. What I'm doing, this will take a, first of all, index. Okay, I is the index in this particular case. Okay, and the index I'm starting with 0. Okay, this is a function call. Next time, this will be unique substring. Okay, here I'll be storing all the substrings to check whether something is getting repeated or not. Okay, so initially what I'm passing for this, I'm passing an empty set here. What is the set, by the way? Set basically hashes the input and stores it. So what happens is that finding something in a set becomes easy. It will take over one time. Okay, that is the basic idea of a set. Okay, yeah. So what I'm doing next, this is the base condition. So what I'm doing is that, so I will see I is the given current index to me. Okay, so what I will do is go from I plus 1 till n. Okay, remember, till n. This particular for loop, sorry, yeah, this particular for loop will go from I plus 1 till n. Okay, remember, in Python, whatever is the last value here, you will have to stop one value before that. Okay, so it will go till n. Remember, these things are very, very important, because the way you are defining the end condition, no, these things you have to be very, very careful. Otherwise, there will be case that this value will never come. Okay, so you will never be able to capture the answer. So this becomes very important. Remember, it is declared till n plus 1. That means it will go till n. Okay, the I and d will go till n. It will go from I plus 1 till n. Okay, what next? I am checking if s of from I till ind. Remember, again, same thing. Whatever is the value here, you will have to take one value less than that. So let us see the worst case here. Okay, so ind will go till n. Okay, that means here this particular string will go from n minus 1 till n minus 1. Okay, so from the current index till n minus 1, it will go in the worst case. Okay, it will not cross that. So we are very clear in that. Okay, so what we are doing here, I'm checking for each value. Okay, and one more thing that I want to show is that, see, why I'm starting from I plus 1, by the way. Can you quickly tell me, if I write I plus 1 here in place of I and D, what will happen? That is, I will get the S of I directly. Okay, that is the simple way of getting S of I. So if I can show you that, see, these things will be clear only if you are solving the solution. Okay, if you have a lot of experience solving the solution, this thing will be helpful to you. Okay, so another way to write this is S of I from I plus 1. Okay, from I plus 1. Okay, so yeah, that is what it is. So both are same. Remember that both are same. Okay, so whatever you are writing here, basically in this place, you have to subtract that by 1, and till then the next will go. Okay, that is the basic idea. So here, basically, in the worst case, it will be the first character itself. In the last case, it will be going till the end of the string. Okay, that is the only idea that I want you to have. Okay, so what I'm checking, if it is not there in my Unix string, okay, what you have to do, first of all, include it in the Unix string. Okay, include it in the Unix string, do a function call, and then remove the same thing from the function string. Remember, why I'm adding it to my Unix string? Because I will be doing another function call here, that is a recursive call here. To that, I will be passing this Unix string. Okay, this Unix string has this particular thing added currently, and then I will be making the function call. Okay, once I return from the function call, remove it, so that when the next in the next iteration, okay, in the next for loop iteration, I can again add something here. Okay, that is the basic idea. Okay, so whenever, remember, in Python, whenever you're adding something and you want a recursive call to happen, after coming out of the recursive call, you will have to again remove it, so that in the next call, proper value is added. Okay, as simple as that. So what I'm checking, if it is not in the Unix substring, okay, only then you have to make this function call. Remember that if it is there in the Unix string, then you have only the iteration will change. Okay, that is, this part will not be executed, then only ind will increase. Remember that. Okay, only ind will increase if something is there. For example, let us say a particular value comes for ind, that is already there in the Unix substring, so I will not be executing this. That is, I will not make a recursive function call. I will not add anything, in my Unix substring. This particular code will not be executed. I will simply go to another iteration for the yeah, for this particular for loop. That is, I will just increase the ind by 1. That is the basic idea. One good thing about this code is that, see, they have clearly mentioned, after concatenating the strings, you should be getting the original string. So this is also an important part in checking that. Okay, so what I'm doing, see, if it is not in the Unix substring, I am not even letting it go. That is as simple as that. Okay, only if it is present, I will be allowing it to go. Okay, so when this case will stop, see, when ind is equal to n minus 1, okay, what will happen? Okay, so what will happen is, see, in the worst case, the way it is defined, okay, this particular ind will have a value of n. Okay, the highest value of ind can be n. When I write here n, then means I'm going till the end. That is the last character of s. Okay, so ind will be n. Remember that. So this particular function call will happen where ind is equal to n, and here I will be coming again. I will be coming here again where I is equal to n, and here this condition will be becoming true. In that case, what I'm going to take, answer is equal to max of any other answer, comma, length of the Unix substring that I have been passed with. Okay, that I have been passed with. So take that. Okay, this part is just to show you how these things are populating. I will uncomment this part and show you that. But yeah, in the original solution, you will have to comment it out, because, see, in LeetCode, what happens that if you are having multiple print statements and you are segmenting that, so you may sometimes get that output limit exceeded error. Okay, that comes only when you are printing a lot of things which are not required. Okay, so this debug prints, you should be commenting before submitting a solution. Okay, as simple as that. And remember, in the base condition, always you should have a return statement to stop the recursion. Okay, so this is the whole idea behind the solution. Okay, so basically what we are doing for each int, that is okay, if I can trace this and show you, see, the idea here is, first what will happen, it will check for w. Okay, if w is not there, yeah, initially it will not be there because the set is empty. So it will include w and start a recursion. Okay, the recursion will go on. Okay, it will reach till the end, but in the second iteration, what will happen, in the second iteration of the first function call, what will happen, it will go to now ww. Again the set will be empty, remember that, because I will be removing it. Okay, I will be removing the thing. Okay, again then it will try for www. Okay, similarly it will try for www like that. It will be trying, going on trying, right? This thing will happen, remember that. But yeah, since you have mentioned this, okay, yeah, we will only be taking the max value. Okay, and in the answer that I'm going to print you, remember that only when the length of the unique substring is answer, that is when this is the one of the maximum values, and this maximum value got transferred to answer, only in that case I will be printing them. Okay, I will not be printing every case here, remember that very clearly. Okay, because otherwise the it will be a very huge output to show you. Okay, so let me just on command it now and show you how it works. Okay, I am on commanding it, and yeah, let me reduce the zoom first. Okay, I have to remove those things also. Just a second. So yeah, this is what it is. We'll go to test case for, because the test case which I showed you here, right? This is the one. Okay, I will be again showing you for this only. Okay, so what happens is that if you see here, yeah, as I mentioned, the answer for this is 11. Okay, if you see here, the answer for this is 11. So see, most of the test cases, no, most of the recursion calls are giving 10. Okay, most of them are giving 10, but only there are one case where we are getting 11. Okay, what is that case? Also, I will show you that. But remember, we are getting 11, and 11 is the answer in this case. Okay, so this is what I wanted to show you. See, this output will be printed only if the unique string that is coming is contributing to the answer. Okay, when length of unique string go to the answer, only then it will be printed. Remember that. Okay, it will not print every case. So coming to this particular test case, now we will try to find out how this answer is coming. Okay, now I will try to show you another way to get this answer. So what I'm going to do, see, one thing is clear. If I can show you that, see, they are taking www. Okay, we will also take the www part, and there are two w's also coming. Okay, there are two w's also coming. Okay, that is another thing, and fb is coming. So we will take these things, and I will show you how it comes. Okay, so what we'll have, we'll have the www first. Okay, right, fine. Then we can have a z, then we can have a f, we can have a v. Okay, we can have a v. Just pay attention here. I'm from here only, I'm seeing it, making the answer. Okay, I can have a f, then I can have a v, then I can have a e again, then D. Okay, obviously I can have a single W also. Okay, now see, remember F is coming, I cannot have F again, so I will have to combine them with V. Okay, I can have FV, I can have a H. Okay, I can have a S because S is not there, and I can have a WW. Okay, so this is the answer. Now let me count it, how many other, 1 2 3 4 5 6 7 8 9 10 11. So yeah, this time here I'm going to have 11. Okay, so in this particular thing, the answer coming is 11. So yeah, if you counted 1 2 3 4 5 6 7 8 9 10 11, yeah. And one more important thing is that, remember, after concatenating them, you should again get the answer. That is important part here. Okay, see, that is also defining the way that we are coding the solution. Okay, if you see here, if it is not in the substring, I'm not returning. Okay, I'm not making the function call at all. Okay, because only, yeah, only if it is not there, only then you will have to make this recursive function calls. Okay, to try the other cases. If it is there in the function, then you should not be trying that. Okay, so the idea here is, the idea behind including this is that at last the answer that I'm going to get, so after concatenating them, definitely I'm going to get the original string back. This is one such way of doing it. Okay, if you do not add this particular conditions, what will happen is that there will be cases where you are getting some answer, but after concatenating the unique substrings, you will not get the original thing back. Okay, that is also happening. Okay, the way in which I showed this particular part, if you follow this approach, there can be a case that, okay, as I showed you, you will have ww at last. So what you have to do, you have to track, you have to backtrack and come to the last part, and I had it here. Okay, so sometimes what will happen, even this will be present, so you have to go back and concatenate these two, something like that. So ultimately you will have to backtrack. Without backtracking, you will not get the answer. That is the thing that I want to tell you. Okay, but in my solution, I'm not doing backtracking as such, because I'm trying, I'm whenever I'm going to the next index, what I'm doing is that I'm trying to explore all the possibilities. So by the time you reach I equal to n, ultimately you would have explore all the possibilities. That is the basic idea. Okay. So yeah, fine. That was all for today. This was really nice question. Actually, initially I also doubted how this schedule thing could be done, but yeah, then I realized this is where I am missing it. Okay, because after going attendance, we are supposed to get those instinct back. This I was not doing. Okay, that's why the answer that I was getting is was not coming. It was failing some of the test cases. Okay, then I improved the solution, got this particular thing. Okay, so I will give you this test case in the comment section, so you can also try your solution with this first before submitting it, because this is something that your code might fail. Okay, so yeah, that was all for today, friends. This was the day 21 of the October Daily Code Challenge. If you like my efforts, please do consider subscribing to my channel. It really gives a lot of motivation to continue further. Okay. Remember one thing. See, ultimately what matters is that whether are we coding every day or not. Because if we are not doing that, then we might be losing something out of our mind, and that particular quickness, that particular spontaneousness will not come in us. Okay. In the interview, we'll have very less time to think, and you should be very very good in what you are already knowing at least. Okay, what you know you should be good in that. That's the ultimate aim, right? So you have to revise those things every day. The best way to do this is go to doing this daily Letcode challenges, because you might not be knowing it, but see, ultimately you will have to use something that you already know. In that way you are getting your that concept refresh in your mind, right? So yeah, please do consider subscribing to our channel. This really gives a lot of motivation to continue further. It will be beneficial for you, for as well as for me, that I get a reason to make videos like this, to solve questions like this, to create answers like this. So yeah, fun. That was all for today. See you tomorrow. Thanks a lot.